In 1911, Ernest Rutherford and his associates Hans Geiger and Ernest Marsden designed and executed their infamous gold foil experiment, determining the existence of a positively charged nucleus.
They used alpha particles, which weigh 4 times as much as a hydrogen atom and are positively charged, thus would deflect off of a positively charged nucleus, proving Rutherford's hypothesis.
I ain't trying to do what everybody else doing. Yeah, 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 yeah. Jane, gold all in my chain, gold all in my ring, gold all in my watch. Don't believe me, just watch.
Geiger represented both himself and Marsden when he argued about the validity of Rutherford's experiment. Geiger and Marsden assumed that the mass and charge were uniformly distributed throughout the atoms of the gold foil. They assumed the alpha particles would pass through without interruption.
The scientists worked day and night in order to design an experiment to test Rutherford's hypothesis.
The scientists bombarded a thin gold foil with fast-moving alpha particles. They expected the alpha particles to pass through with only a slight deflection, and for the vast majority of the particles this was the case. However, when the scientists checked for the possibility of a wide-angle deflection, they were shocked to find that roughly 1 in 8,000 of the alpha particles had actually been redirected back toward the source. After thinking about the startling result for 2 years, Rutherford finally came up with an explanation. He reasoned that the rebounded alpha particles must have experienced some powerful force within the atom, and he figured that the source of this force must occupy a very small amount of space because so few of the total number of alpha particles have been affected by it. He concluded that the force must be caused by a very densely packed bundle of matter with a positive electric charge. Rutherford called this positive bundle of matter the nucleus.
Eureka! Rutherford had discovered that the volume of a nucleus was very small compared with the total volume of an atom. In fact, if the nucleus were the size of a marble, then the size of the atom would be about the size of a football field. Rutherford also suggested that the electrons surrounded the positively charged nucleus like the planets around the sun. Not only did Rutherford receive knighthood and an Order of Merit award, but he was awarded the Nobel Prize in 1908 for his investigation into the disintegration of the elements and the chemistry of radioactive substances.
But that's just how